Welcome back to Calculus AB, everybody. Today's topic 5.8, 5.9. We are continuing with part four of this section. So we're still looking at, again, the graph of f prime and then drawing a possible graph for f of x. So we're going to continue with that. We're going to start off with an analysis of f prime of x. As always, as I've been telling you guys before, make sure that you guys start off with where is the function f prime of x? Where is it positive? Where is it negative? Because that's going to tell me where f of x will be increasing or decreasing. So here, we're going to start off to see where is it negative, right? So we're going from negative infinity all the way up to negative 4. That's where it's negative. Change the sign, becomes positive, and then when it hits 3 again, right, all the way up to positive infinity, it's negative again. So we're going to say that f prime of x is less than 0 on negative infinity to negative 4 and from positive 3 to infinity. And again, this will imply that f of x is decreasing on those intervals. And 3 to infinity. And then we're going to look at, again, when is it positive? So now f prime of x is greater than 0. It's positive on the interval between negative 4 and positive 3, right? So anything that is above the x-axis. And we're going to say that f of x is increasing on that same interval. Now we're going to start looking at f double prime of x. So f double prime of x again tells us whether the graph is concave up or concave down depending on the value of that, right? So f double prime of x. Now, if you guys notice, we're going from negative infinity all the way when we reach positive 1 here, the graph has a positive slope, right? If I were to draw a tangent line there, it would have a positive slope every single time. So we're going to say that f double prime of x is greater than 0 on the interval from negative infinity to positive 1. And therefore, we're going to say that f of x is concave up on that interval. And then if we look at when is it negative, so f double prime of x is less than 0 on 1 to positive infinity, meaning that f of x is concave down on that same interval. 1 to positive infinity. And then again, when f double prime of x is equal to 0 or it's undefined, we can say that right here we have a point of inflection. So we're going to say that f of x has a point of inflection at x equals 1. And then let's look at the relative max and the relative min, see if we have any of those. So at negative 4, we changed from negative to positive. So that means that this is a relative min. And at positive 3, I changed from positive to negative, meaning it's a relative max. So we're going to say f of x has a relative max at x equals positive 3 and a relative min at x equals negative 4. And with that, we can start drawing our graph. Now here it says possible passing through the origin, so I want to draw it right there. So again, it's concave up from negative infinity to positive 1. So this is where it changes concavity right here. And then we have a minimum at negative 4, which would be over here, somewhere here. And then we have a maximum at positive 3, so somewhere up here. So we're going to say our graph kind of looks something like that. So again, there's a minimum. And then changes concavity right there. And then it starts to decrease again when it reaches the maximum value. So that would be a possible graph for f. Now looking at example h here, we have f prime of x is equal to, and then we have this function as always, right? So again, starting with our analysis, we're going to look at where is it positive, where is it negative. So we're going to say that f prime of x is greater than 0, right? We're going to start off with a positive up pretty much until it reaches 1, right? So on the interval from negative infinity to positive 1. And then again, this implies that f of x is increasing on that same interval, right? On negative infinity to positive 1. So we're going to say that f prime of x is negative on positive 1 to positive infinity. And that again, that implies that f of x is decreasing on that same interval again. And then f double prime of x is less than 0, right? It's decreasing on, here we're looking at when it hits 1 again, right? So from positive, or no, it's actually always negative. So it's always negative on negative infinity to positive infinity. This is always decreasing. And with the exception, right, except at x equals 1, because it seems to be undefined right there. So we're going to say that our graph is always going to be concave down, right? So f of x is concave down from negative infinity to positive infinity, again, with the exception of 1, right? And then we can also say that here, it's f of x has a minimum or maximum, because we're going from positive to negative, right? So therefore we have a maximum. F of x has a relative maximum at x equals 1. And here we don't have any points of inflection, right? So f of x has no points of inflection. So looking at example I of f prime of x, we have the graph here, and then again, we're going to be drawing the possible graph for f of x. So starting with our analysis, we're going to see where f prime of x is greater than 0, meaning it's positive. So we're going from negative infinity until it reaches positive 1 right there. So on the interval, negative infinity to positive 1, and it's also positive from positive 3 up to positive infinity. So therefore, we can say that our f of x is increasing on those same intervals from negative infinity to positive 1. It's an 8, sorry. Okay. So negative infinity to positive 1, and from 3 to positive infinity. And then we can also see from the graph that f prime of x is less than 0 when on the interval between just 1 and 2. So therefore, we can say that f of x is decreasing, right? Is decreasing. Oh, actually, there's two intervals, not just from 1 to 2, my bad. It also goes from 2 to 3, right? Because of the asymptote that's right there in the middle. So, and from 2 to 3. And then we can say that f of x is decreasing on those same intervals. So on 1 comma 2 and 2 comma 3. Remember, these are open intervals. And then on the next one, we're going to start talking about f double prime of x. So let's see what f double prime of x is less than 0, right? Where do we have negative slopes on this graph? And if you guys notice, we have negative slopes until we reach positive 2, right? Because that's where the asymptote is at. So it's always going to be negative going from negative infinity. So on the interval from negative infinity to positive 2, where the asymptote is located at. And we're going to say that f of x is concave up on that same interval. So f of x is concave up on negative infinity to positive 2. And then also we're going to see that f double prime of x is greater than 0 when it's positive on the other interval. So it's going to be from 2 to positive infinity. And again, this implies that, sorry, this is not concave up. This is concave down. So when f double prime is negative, it's concave down. My bad, sorry. So f of x is concave up because f double prime is positive. So it's concave up on the interval from 2 to positive infinity. And then from there, we can say that f of x, right, by looking at the graph, here we're changing from positive to negative and then from negative to positive. So we know that at x equals 1, we're going to have a max, right? So there should be a max here. And then at x equals 3, since we're changing from negative to positive, we're going to have a minimum there. So let's write those down in our analysis. We're going to say f of x has a relative minimum at x equals 3, and f of x has a relative maximum at x equals positive 1. And then we can see here there's no points of inflection because there's nowhere where f double prime of x is equal to 0. And then let's create our graphs. So again, we're going to have another asymptote at x equals 2, right? The function is undefined for both of these right there. And then we have a minimum at x equals 3. Since we have a minimum at x equals 3, it might be somewhere up here. And then the other one's going to be at x equals 1. It might be somewhere down here. And then again, our graph is going to be concave down from negative infinity to positive 2. So that means that we have like a downwards parabola going down like that right here. And also we're going to have an upwards parabola going on this side right here as well. So that's a concave up and then our concave down parts. And then looking at J, our last example here. So again, we're going to start off to see where does f prime of x is greater than 0 because it's not less than 0 at any moment here. So f prime of x is greater than 0 everywhere except at negative 2. So we're going to say on the interval from negative infinity to positive infinity except at x equals 2, negative 2. And therefore, we're going to say that our graph is concave. It's increasing. F of x is increasing on that same interval because it's always positive. Except at 2, right? Negative 2. And then we're going to look at f double prime of x. So f double prime of x is slopes, right? If you notice here, the slopes is always negative until we reach negative 2. So it's less than 0 on the interval from negative infinity to positive 2. Negative 2, I'm sorry. And then we're going to say that f of x is going to be concave down there. Concave down on that same interval. And then f double prime of x is positive on the interval from negative 2 to positive infinity. And then we're going to say that f of x is concave upward on that same interval. All right. And then here, since we don't change, right, f prime of x never changes sign. It's always positive. We're going to say f of x has no relative extrema. And then finally, we're going to say that f of x has a critical value here. So f double prime of x would be undefined. So we're going to say that it has a point of inflection. Has a point of inflection at x equals negative 2. And then the possible graph for this, again, negative 2 is right there. So it will look kind of close to a cubic function. And it goes back up. So it's always increasing and so forth.